So, hello and welcome to our first English webinar in our series about open source tools for industrial IoT. We initiated this series after, usually the series is in German, because it's basically targeted to the German small and medium-sized companies to help them a bit get the right knowledge. But as the community is quite big in PLC4X and multiple people asked for this webinar, we are happy to do the webinar in English today. And if there are other topics where we have the same interest, we can definitely think about doing the whole series in English also, as it's simply easier for all the world to listen and to understand. I am happy that we are pretty widespread today. We have attendees from multiple countries, from not only from Germany this time, but also from Austria and even from China. John, hope you're not so start and then directly dive in. Some short organizational things. If you have any questions at any point in time, just write them down on the right side into the panel, and then we will try to answer them as best as possible. With me is my friend and colleague Tim. Tim, say hello. Well, Tim is a bit shy today, as it seems. Okay, then probably he's preparing his demonstration. Okay, so I will stop my cam now as the internet connection is not that good, and I hope everybody can see my screen, and we dig right into the slides. Or perhaps before we start, I prepared very small or two very small polls. I will start the poll now. This should be available now also in the right side where you have the speakers panel, just to get a small insight from us what your background is. Do you come from the IT side or from the OT side? Okay, or somewhere else. Okay, so most of the people are here are from the IT side, so it makes sense that we show a bit about the OT world. This is what Tim is currently preparing. And another small poll I prepared. Did you ever hear about PLC4X? Some people I know heard of it, probably through me. Oh, everybody. Excellent. So I hope that it's not too low level, but yeah, if there are some more questions, just write them in and we try to dig a bit deeper, basically. Okay, today so ready to in the first section, give you an overview, an introduction to PLC4X, what the intention is, a bit how it's built. But in the second part, we will really go into code and we'll show my IDE. We have an S7 prepared. I will do a live demonstration on how to read stuff. The code all the code I show is public on a GitHub repo, and you can find the link on the Pragmatic Industries webinar page. You may know, otherwise just ping me or write me an email, and I will show you the site. It's all public. Okay, this is the setup of the whole webinar series we are doing. Currently, we have planned 10 webinars over the course of 10 weeks, basically. We start from the edge into the cloud, and then we go a bit into the operations thing. So what if things scale? How to manage multiple devices, do updates and stuff, where Hotbit comes in. Or if I have a large variety of things where Water comes in, how to manage all those descriptions. Short background from ourselves. Who am I? I'm Julian, as already said. I am by heart mathematician, and I have a long story with the PLC4X project. I was one of the first contributors to the project back then when I was young. I'm a long-time member of the PMC, and the things I usually work on are the networking stack with NetI in a Java implementation. Oftentimes I'm doing the releases. I wrote a module object PLC mapping, OPM, which is a bit like JPA. So you have POJOs where the getter magically make a call to the PLC, really a bit like JPA if you know it. I wrote a connection pool, a new connection pool implementation, and I worked a bit on the Siemens driver. So this is the stuff where I have really deep knowledge, because a big part of the code is written by myself. With me is, as I said already, my friend and colleague Tim, who's an electrical engineer, and who's also a longtime member of the PMC. And his focus is definitely on the S7 side of things, also Modbus, because we have it in production. He wrote the connection scraper himself, and he does a lot of manual testing, stability testing. This is something which we usually do internally in our company before agreeing to go on a release, because we have multiple instances in production. So therefore, we usually do quite some tests, quite some heavy testing, and have a good feeling about what you can do and what not, because we're big user group of PLC4X basically. Okay, now to the introduction. Perhaps on a side note, some trivia for you. Who knows what type of animal this is? Any ideas? Okay, don't know. Nobody an idea? It is. Oh, so good. I give the answer now. Yeah. Cat is nearly right. It's so-called toddy cat or palm civet. These are most well known for producing the pretty expensive coffee by digesting the coffee beans. Yeah, Shangdong got it right. Palm civet, and the reason why we have the palm civet as mascot is because it has all the letters P, L, and C in the right order in its name, and it's cute. So it makes a pretty good mascot. And as the palm civets are also called toddy cat, its name is Toddy. Okay, so now going over to the real facts. Yeah, this is the slide you always have to do, the digitization industry 4.0 slide. You have to have in every talk. It talks about how to gain improvements in the machine, or how to go forward the steps to industry 4.0. And a crucial step is step 2 here. Step 2 is connectivity. This is a very simple thing for us from the IT world, because I mean, basically we have only one kind of network nowadays. Just plug everything in and everything talks with each other. The times are over where you bought a new PC and were uncertain if your old printer still works with it, or if there are drivers. Everything works with everything nowadays. But this is quite different on the machine level. To give you a background, most people have no OT background. To give you some background about that, up till today, most devices talk mostly with proprietary protocols with each other. So there are still situations where you have to buy a new device from a specific vendor only because it has to communicate with another device, which is from the same vendor. So it's I usually say it's not Facebook who invented this locked garden thing, but it's the shop floor guys who invented it. So they really have this vendor login thing established there. People are so used to it that nobody thinks about it, basically. These protocols are usually incompatible, and even for single vendors, new versions of the device may have different protocols or outdated protocols. So it's quite complex. There are some standards protocol. Also the shop floor, a very old one is Modbus. Ethernet is newer, and the newest one is OPC UA. APC DA was it's a bit older. And those protocols are supported by several devices for specific purposes, but usually it comes at a price, because all the functionality a device or a PLC controller provides is only supported in its native protocol. It can do some things via, for example, Modbus or Ethernet IP, but not everything. So there is overall no universal way to communicate with industrial hardware, and especially no open source way. So there are some vendors that have open source specifications, at least. There are also some vendors that sell drivers for their specific PLCs, but some of them, for example, are tied to Windows, as the whole shop floor runs on Windows. We, from the IT side, oftentimes prefer Linux, as it's easier to orchestrate, to maintain. So we would like to have the source code, of course, to port it. Then there is this new standard, OPC UA, which is not that new. It's about 10 years old, but just now got the right traction. So since 2 or 3 years, everybody's talking about it, and every controller has it implemented, basically. So this will definitely be the future. But currently it has no significant market share to rely on it for a solution. And I will talk a bit more about OPC UA in the next slides. So why, as connectivity is so important, as it's, I mean, nobody does it for itself, but connectivity is just the thing that you have to do all the other nice things you can do later on with the data. And the open source solution PLC4X, there's a question. I will answer that question later on, as I have specific slides for OPC versus PLC4X, as there are indeed advantages. Back to this slide. Some things the open source and generally an open source implementation gives you is, for example, flexibility. This is a bit special for PLC4X, as we decided to not only provide a set of drivers, but to provide a single API. I will show an example of that later on. But of course, flexibility applies also to hardware, as currently there's an effort undergoing in the project of someone trying to port PLC4X to C language to have it run on a really constrained device. And this is the flexibility you have as the source code is open, and you can change the project, basically. The cost model is totally different. Open source software is, I would say, never for free. At least you have to invest time, at least. But sometimes when you are lacking the knowledge, you have to pay someone to do something. But this is quite different from all the subscription models that are currently coming up. So you can decide for yourself whether you want to invest 1 week or 2 weeks once, and then you are done, basically, or you want to rely on a solution. You have to pay subscription costs every month, every year for every developer or something. So you're quite flexible with how you want the costs to be. It is extremely extensible. Basically, we have several drivers that have been written by different people from the community. And if we stumble upon a protocol which we don't know and which we need, then we can just implement it. Especially for PLC4X, we have a special mode of operation, I would call it, which is secure by design. Basically, it's a passive mode. So we only listen. We do not send messages on a bus. We only listen on a bus and decrypt the messages to basically understand the communication. And if you now have specific firewalls rules or even specific hardware, which really only lets network flow through in one direction, then you can totally securely read PLC values from the communication. And what we try to provide from the PLC4X team is a wide range of examples and integrations with existing tools. One of those tools I will explicitly name is IoTDB, which I will present next week in our webinar series. And we have a nice little example of PLC4X working together with IoTDB to store a large amount of PLC data, basically with very low memory usage, as it's very efficient. So what exactly is PLC4X? This is the mission statement we started with and we still have. It's a collection of libraries for communication with industrial PLCs, and also some other protocols that are used at the shop floor with a common programming interface, and this is quite important. So this is the overview picture about the architecture. So the idea is you have the PLC4X API, as you see it here. Below the API, you have several implementations of totally different drivers, ranging from S7 from Siemens, over Modbus, OPC UA, other drivers. And above, you have your own application, or, as I said, some integration examples. And the approach we took with PLC4X is pretty similar to JDBC. I guess most of the people that are familiar with Java programming know JDBC and the JDBC API and the idea behind. So you do not need to know at compile time what kind of database you will use later on. You only have to ensure that it's later on in the class path. So it's only dependent on the configuration string, on the connection string you give it. And this is exactly the same architecture we use here for PLC4X, and you will see that later on in the hands-on example. Okay, here comes a bit of a comparison, PLC4X versus OPC UA. As most of the time you speak to OT people and say what PLC4X is, they say, okay, so it's like OPC UA. And yeah, the answer I usually give is same, but different. I will start with a little example and talk a bit about the pros and cons of OPC UA then. Let's imagine you have several devices at the shop floor, several machines and tooling around and stuff. And you want to write one application which needs all the data from it. So if you have an OPC UA client, you can spin it up, and you can hope that all your devices support OPC UA. Not all devices will, especially older devices will not support OPC UA, or constrained devices will oftentimes not support OPC UA. So there's the first showstopper, as you cannot integrate all devices. I mean, they're usually, the people working at the shop floor are quite clever and are really good at solving problems. So what they will usually do is to take one of the controllers to talk to the Modbus device, and then if the controller has data from the Modbus, it can give it over via OPC UA. But this is not such a clean solution, as it needs, for every change in that area, it needs to have a change on the machine, both the PLC program and of the program you are running, which is not good encapsulated, as we would call it from the IT side. So this is really the one of the main main downsides of OPC UA is that it really has a non-significant market share on brownfield. On the other hand, OPC UA has some really nice advantages. Most of those very old proprietary protocols are pretty basic. So some of them even only talk about bits and bytes. So you just say, okay, give me 3 bytes from offset X. And it just gives you 3 bytes from offset X. For example, with Siemens S7, it is like that. So you have no idea to know what's in there. Is there an integer in there? Is there a double in there? Is there a string in there? You have no idea. And OPC UA comes with a rich data model. So you can start to ask the PLC, okay, what kind of values do you have? What data types do you have? When were these values measured from the sensor and all that stuff? So OPC UA has the big advantage that it makes it way easier to see what kind of values you have, and it makes it type safe, and it gives you a quality of services, and it gives you quality markers for specific signals. So there are really situations where it makes a lot of sense to work with OPC UA. And if you may have paid attention some slides before, there is an OPC UA driver for PLC4X, because if I have a PLC which has a nicely configured OPC UA interface, it's easier for me to use it. On the other hand, One of the downfalls I already said is the market share, and the other downfall is that OPC UA, due to this richness of the protocol, brings a lot of overhead. So OPC UA is nice if you poll every second, for example, for a value, for some status values, for example. But if you have, let's say, a motor running there and you want to monitor the current of the motor with 10 milliseconds, then OPC UA is not a good fit. As the protocol is just too big or too verbose, then you might prefer to use the native protocol, which is what we do with PLC4X. So yeah, it really depends on the use case. And sometimes, as I said, you might even use PLC4X and use the OPC UA driver, as it gives you the flexibility to change the program then to a non-OPC UA machine. And I will show an example for that. I hope this gives a bit of an answer to the question. Yeah, here's a bit of a comparison, as I said. Most of the things are already said. So OPC UA is quite nice in many situations, but it's not the silver bullet some people sell it for, basically. Here's the same example now with PLC4X. And as this is a PLC4X presentation, of course, it looks nicer now. So how would you solve the problem with PLC4X? Basically, for the application programmer, everything would stay the same, as there's only one API. But under the hood, there are several drivers now, which are available to talk to all the protocols. So from the application, I do not see any difference, as I just issued a call to the API. But then it is under the hood, it's quite different, as every message to another device basically gets over another channel and over another native protocol. But we abstract it away from the application. This is an overview of the protocols we currently have drivers for and we currently support. Especially in, I would say, Central Europe, Siemens and Beckhoff are very, very widely used. So with those two, you cover already a lot. Then there's Modbus, which is used a lot for home automation or building automation, I have to say, for larger buildings or plants. Ethernet IP is a standard which is used a lot in the US. As I said, OPC UA we also support, and then several Allen Bradley standards, which, for example, we implemented as we needed it for projects, so we had to sit down and write a driver. There are some protocols we're working on. BACnet is also important for building communication. Amazon Delta V, KNXNet is also important for buildings and for home automation. This is mostly driven by Chris, the initiator of the project, who wants to talk with his house via PLC4X. So he implements the KNX protocol. There are several protocols we would like to implement. With most priority, the new Siemens S7 protocol, S7 Plus. But there are some legal issues. If we can implement it, how we can implement it open source without breaking basically rules and getting into a lawsuit. And Profinet is also a protocol which will be a bit different, as you need to have some kind of real-time guarantees, which we not know yet how to solve. So now we come to the most interesting part, to the hands-on part, the part where things can go terribly wrong. We did some testing before, and we hope that everything goes well. But let's see. What we will show you now is we have one Siemens S7 1500 running in the basement of our company's office. And I'm connected via VPN, so I should be able to talk to this PLC. This is like the most obvious use case, talk to PLCs. And another thing we will show you is to talk via OPC UA to an OPC UA simulation server, which is running on Tim's machine. So we are also connected via VPN. And we will show you now first two programs, for two programs for both use cases, and then finally, I will show you one program where I change the parameters only via program arguments and do not change the code at all and talk to two totally different protocols. Because this is like the demonstration where you see why this common API is such important and such a cool thing to have. Okay, now it's demo time. I will start sharing my screen. So now you hopefully see my screen. Tim, can you give me a bit feedback about that? I hope everybody sees my screen now. We'll look back. Yeah, okay, excellent. So I will try to give you a short walkthrough through this program I prepared. As I said before, I will upload the program later on. I'm at home. I have only one screen, so I try to jump around a bit via to see the chat at the same time. Perhaps Tim, you can unmute yourself and tell me if something's written in chat or some questions occur. Okay, so the first thing we need with PLC4X is a driver manager. We call it PLC driver manager. So this is pretty similar to JDBC, where you would instantiate a driver manager to start with. And this driver manager then gives you a connection. Again, pretty similar to JDBC. This is the line here where I say driver manager.get connection. And as an argument, I give the connection string, and this connection string is built up like a regular URL, I would say, but the prefix here is similar to JDBC, specific to the protocol I want to use. So S7 indicates I'm talking to an S7 device now. OPC UA has a different prefix. You will see it in a minute. And then depending on the protocol I use, I can give some settings. Or again, via this URL string. So this single string configures what kind of device and what specific device I'm talking to. This get connection is wrapped inside a try catch. As this get connection, this connection here is auto closable. So again, similar to JDBC API. So when I will now comment out all the stuff here. So if I run the project now, all that will ideally happen is that a connection is established to the S7 device and is then closed at the end. Let's see what happens. I will run the program. I will show my console. Yeah, it's okay. So I hope you can see the log. What you see here is some logging from PLC4X, and now it's setting up a connection, and you see it talks about MQ caller values and MQ callee values and PDU size. This is internal stuff of the protocol, and then it says connection established. So it was successful. In the end, there's a warning which can be fired sometimes if the PLC doesn't hang on correctly. But this is, I assume, caused by the latency I have via VPN. So it works and we get the connection. Nice. So the next thing we want to do is to read a value. This is done in the code I show you here. From this connection, we get a so-called read request builder. We use the builder pattern here, as you can not only ask for one value at a time, but many protocols support that you ask for multiple values at a time. So you would just say add item, add item, add item, add item, and would ask for several items. This thing gets a key. This is our internal key just to find the item back in the response. And here is the second part of the configuration. Basically, this is the address where I want to read from, basically. And this address now is always, we try to always keep it as similar to the native protocol as possible. And you will see it when Tim shows the configuration of the PLC. So just skip this cryptic looking format for a second. This is basically what Siemens invented for the S7. Here we're asking for a data block, and then at offset 0, we want to read an int. We built this read request, and then we execute it. And as you see above, it gives you back a future, so it's asynchronous. If I run the program now, let's see what happens. Okay, so you see my two loggings are printed out. First, connection established, and second, request sent. So it seems to work. So the next thing that happens is, of course, to get the response. In this setup, we just do it synchronously. So we just call a get on the future. This is standard Java API. This get will block until the future returns. In other situations, you might want to do other stuff now and just handle the future totally differently by after the execute saying something like handle, so to handle the response in different thread. That is nothing more to do here. So we just wait for the response, and this response object wraps the response from the PLC, and there are two things we can ask the response for. The first thing is a response code, and here we give it this key. As I said before, we have this item here, and we give it a name just to find it back. So what we get here is a response code for this field, as it may not always succeed. For example, this address I entered here could be invalid, as there is no data block 444, or I might not have the permission to read the field. So this response code is a bit similar to HTTP response code. You might know. We have a data type here, PLC response code. So you see the codes are OK, not found, access denied, invalid address, and so on. But coming back to our example, ideally, I would like to get an OK here. So I run the program again. Let's see. Okay. Run the program again, and we'll see what happens. Okay, yeah, we see here what I hope to get. Status of response is OK. And if the response code is OK, then there is a payload in it. Then we can just say response.get, and now as many protocols are untyped, as I said before, and basically just ship a byte array physically over the wire, I have to know what type to expect and call a specific getter. So we have get, you see, float, object, short, int, and so on. Or, so get integer would just say, OK, give me back the value you got and interpret it as integer. Interpret does not mean interpret the bytes as integer, because above here we give it the type, so internally it knows what kind of type this is. But for example, if I would now say get long, but I ask for an int, then we will automatically cast it to a long. I mean, from int to long is not so interesting. But if, for example, I said get double, then we would give you a double. So we will do the conversion automatically whenever it is possible. So and what I can always do is to say get object. Then I will get the value in the Java type we by default assign to int, which is an integer in this case, or a short. I think, I'm not sure. Could be a short. Yeah. So let's stick to get integer, and now I execute the program again, and we'll see what happens. And ideally, I get the value. The value I will get will most likely be some garbage, as I just point somewhere, and I have no idea what's really written there. Okay, so it's 17,820. Okay, yeah. So this is the very minimal working example. You got here basically hello world PLC4X. So this is the code you can start with, talk to your PC. And now I will stop sharing my screen and give over to Tim, who will show you a bit of the configuration of the PLC and where these addresses come from and what you have to do on the PLC if you want to do this demo with your own PLC, what you have to do with your PLC to get it running. Tim, we don't hear you yet. We still don't hear you, Tim. You could try to just refresh the browser session and come in a second. Just refresh the browser. So just a second. So what Tim, I will already start talking a bit. Tim will now show you a program called TIA, Totally Integrated Automation, which is the program from Siemens you use to program those PLCs. Yes. So
do you hear me now? Yes, okay, fine. So I will share my screen. Okay, you see my screen?
Excellent.
Okay, you see my screen? Fine. So welcome from my side. So had some problems with the mic. Julian, I hear me in,
I don't know.
in echo.
I can try to
maybe.
mute myself.
Yes. Yeah, no, it's better. Okay, fine. So just to give you a short excursus to TIA, as Julian told, this is the program from Siemens for developing this automation programs for this called TIA portal, Totally Integrated Automation. And yeah, this is the one we have. So as Julian told, we have an S7 1515 in our cellar in the office. This is a widely used S7 protocol, which most of the machine builders will use in their configurations. So it's quite common. So the first thing that is quite important is that the connection mechanism of the F7 is set to this one. This is the put-get communication. This is usually used to communicate with some HMI system for like the machine users can interact with the machine. And this is also important for us to communicate with the S7. So this is the very first important stuff to activate when we want to communicate via PLC4X with an S7. The next one is to give like full access, but this is usually used when machines are communicating with HMI, so it's usually activated. So this is the most important regarding like the basic configuration of the S7. And the next important thing is Julian told about we currently support this F7 COM protocol. We are planning to do this S7 COM Plus protocol. The difference is I can maybe show. So usually when you add a data block, this looks like that. But usually when I create a new one, I can just do this. Some name, doesn't matter. So what Siemens does is to make this block non-optimized. What you realize that you don't have any offset row here. When I go to the block I usually use, we have this offset row. This is due to a topic the S7 Siemens introduced this optimized blocks because they have an axis optimization built in there. So this one, the blocks are not in an order, but in a specific kind of order where we can't access offset. And yeah, when we sometimes check this legal issues and integrated the rest, then we can also read out this optimized blocks. But currently we have to adjust the blocks to a not optimized axis. This you will do if you can click on the data block and switch to the properties, and then you have some attributes here. And here is this optimized block axis. So when you usually create a block, there is like a little cross here, but we don't want to activate it now. This is the optimized. So we have to use to sum it up. We have to use the non-optimized blocks. So this is the block Julian read out something, and we have a different kind of data types in the S7, and the Siemens uses usually data types that require 1 byte. So this is kind of unsigned integer, bytes, characters, and so on. And then 2 byte integers, 2 byte data types like int or unsigned int, like this kind of here. You see, like it's just uses like 2 bytes. And
asking, is everybody able to read Tim's screen? On my screen, it's pretty small, but I have not that big a screen.
I size it up, but I can.
It would be cool if you could set the resolution a bit lower or something. Ah, way better.
No, it's better. Yeah, I learned to use.
Okay, excellent. Yeah, better. That's better for the explanation.
Okay. Yeah. Okay, fine. So and we have this 4 byte long data type. This is the real. The real in Java would be like a float implementation, or a double integer and stuff like it. So what uses 4 bytes. And I just made some overview, like this kind of where Julian stated about. This is like the old address usage. So this is this %db means this is a data block on offset data block 444. You can see here. Wait a second. This is the data block number for the axis. Then we have a dot, then a db for reading out from a data block, and then we have like those 4 possibilities. As I stated, this byte is 1 byte long, word 2 byte long, d for double word 4 byte long, and we have an x. An x is what not fit into the conditions before. So for example, if we want to read out a bool, the bool is just a single bit. So we have to use this x, or when we want to read out a string which is longer than the 4 bytes. So this is the old notification, and the new address notification, because TIA knows, we just give the expected data type over, like bool. So we don't have to use like this notification because it's like redundant. So let's go back to this. yeah, this is the data block we usually use for, we have like a machine simulation. And yeah, I think this was like a quite short introduction on S7 usage. So maybe Julian, you want to go on? Julian?
Okay. If not, you have to stop share screen, then I will share my screen. And I will go over to my IDE. What Tim, you can see my screen now? I hope. Yeah, exactly. Okay, so what
Yes.
Tim now showed you is how or where you have to look in your PLC program to find out the values you're interested in and what you have to do that they are accessible. And basically for the exact block that Tim showed you, 444, I prepared another short demonstration, which is more like a real world scenario. It's basically pretty similar to the first example, but it's more like a real world example. So we again start with a connection, and here now you see I use the builder pattern as I want to read 4 values concurrently. First one is a position, and this is one of the values Tim showed you with the offset 0 as a real. The second one is a random value, which just get generated in there. The third one is a current from a mode, from a simulated current in this case from a motor. And the fourth example, just to show it, is a field that does not exist. So it's not syntactically a wrong address. This would lead to a different error, but it's an address which is syntactically totally valid, but which simply does not address on the PLC. Again, I just execute the request. I will get the response. And what I do here now, this code here, is I just check the response code. And if the response code is OK, then I will call getObject. In this case, I have to call getObject because I have different fields with different types. And I will just print the value for the field. And what I can do in the response here is to call getFieldNames, which will just give me an iterator over those 4 values. So this is the easiest way to read a request with multiple fields, if I do not want to do something specific with all those single values. So basically, I get all field names, then I print out, just for the sake of this example, I print out the response code, then I check the response code, and only if it's OK, I try to access the payload. If I would try to access the payload when the response code is not OK, I get an exception, as there is no payload. So now I will start the example. We'll see what happens. OK, so this looks good. Basically, sorry. Let's make it a little bit small. So let's look at the log. The log states are in German, as I did not adjust them from the last webinar. So basically here I get the response, and then I go over motor current, which is OK. Payload is 27. Then the not existing field is checked, and the response code is invalid address. Which is what I would expect, as the address does not exist. So I don't try to access the payload. Then I get a value from the position, which is OK and has a value of roughly 2000. And the random value has also a valid payload with some random value. So this is basically the minimal example if you want to start doing with a real PLC, with a real program running on it, and you want to start doing something like visualize if the machine is running or not, with what speed it is running. This is basically the way to go. You just take this code as is written here, put in multiple items in the request builder, and then you could just do a for loop around the whole thing, basically, and execute the request every second or every 10 seconds or whatever. And then you have the simple scraper, which fetches all the values. And the values here you could just take and send them via JSON, write them to a DB, visualize it on a UI, whatever. Some notes, they do not have to be from the same data block. They can be from different data blocks. That's the first note. And the second note is, some of you may or may not know, there is a limit of the message size, basically, the PLC, in this case, the S7 PLC, can send with a single request or in a single reply. If you do something here which would lead to a request or a response bigger than this maximum size, we split it up for you under the hood. So we basically do or multiple requests, then fetch all the requests together, and then give it back to you as one single response. And this is quite comfortable if you don't want to care about these details, because if you start with a real world example and people are like, okay, take this data block and this data block and this data block, and you just import them from a CSV export of tier or something, then you suddenly end up with something being too big for the PDU size. So the maximum message size is roughly 1,000 bytes, and this is something you can easily cross if you read several 4 or 8 byte values. So this is really the simplest example, simple real-world example of reading values from a real device. So now I will go over to a different protocol, OPC UA. I will first show you the code, and then Tim will give you a quick overview on basically what's running on there. So the code starts pretty similar. We call a get connection, and then you see the prefix is different. It's OPC UA colon TCP. Then we have the IP address and the port and some prefix. It's a simulation server we run here. And here you see we give it several path parameters, because in this case we run OPC UA with authentication enabled. So you need a username and a password. And this is something we give it from the path parameters. We do it via path parameters and not via a different method or something, because we don't have to change the code then. So if I start the example, I will build up a connection to an OPC UA server, and then we will read several fields from there. And you see here the syntax is quite different. What you see here is basically default OPC UA syntax. This is how the OPC UA variables will look like in your node tree. So again, it's quite easy for you to get the address from your engineer or from the program or from the OPC UA server. You just look up how it looks there, write it down here, and you have the right address. And again, we have several fields and a non-existing field. Just to demonstrate it, we again call the future. So the code is in fact exactly similar, but I will show it in the final example. Again, we iterate and then see what comes out. So let me start the whole thing. Then we will see if it works. So probably we can look on the log for 1 second, because you get here some logging from PLC4X, from the PLC4X project. And what you see here is it's instantiating a new driver manager, and you see here it registers the driver manager for protocol S7 and the driver manager for protocol OPC UA. So during the compile time, I do not have to care about which protocols I can run or not. It's only via the runtime. And the logging here tells me that both protocols are available there. Okay, so in the meantime, the program has run through and worked. So you see here again, I get a connection established, request sent, request response gotten, and here the details of the response. So the value counter has a response type OK, and a value 28, and same for triangles, sinus, sawtooth. and the not existing field, in this case, get a not found. So again, we can use exactly the same code without caring too much about the underlying protocol. I will switch over to Tim for a second, which shows you how the setup for this OPC UA case is. Let me stop sharing my screen.
So,
yep.
You understand me? Okay. And I hear you in the echo, Julian, can you just, yeah, fine. Thank you. So, yeah, as Julian told, we are using for this demonstration like this process OPC UA simulation server, which is free to download and free to use for like testing and stuff like that. So the good thing for that is that it usually supports any operation which you can imagine due to OPC UA servers. So you can adjust then different endpoints, security modes, also like user access. We just entered here, like this is the user tester. We just entered with a password. But you can also create some certificates for that.
A bit small.
Okay. I'm sorry. So wait a second. Okay. Here. So now better? Okay, fine. Yeah, so we can use the certificates. It's just a logging to check if everything's going as we expect it to be. The address space is, wait a second, here. Yeah. So, yeah, these are the fields Julian told about. Sorry if it's not working quite fine, but yeah, those are the addresses we just wanted to read out from my server. Below here you see it's those yeah, the real values, like the one increments, the other one is like a triangle, some sawtooths and stuff like that. It's some basic functionality which is included in this OPC UA server.
Ending time.
And
not too much details of the OPC UA server.
Okay. Okay. All right. So yeah. So just what I wanted to say, it's the addresses here you can extract from the special field what you want to have. So this counter is like NS5. I can go NS5 counter 1, and the sawtooth is NS5. Sawtooth 1 and so on. So it's quite a good tool for just when you want to try with an OPC UA server, because it's set it up. You just have to download, start it, and enter what you need, and then you're done. Okay. So I will switch over to Julian. Thank you.
Question already start to put them down. So the final example is pretty simple and fast. It's in fact pretty similar to what you've already seen. The final example is called Single API Demo. You can see my screen, I hope. Yes, looks good. So it's just a program which has the code which is similar to all the code we've seen so far, with the only difference that it takes the connection string as well as the field string from the program arguments to show you that it's really compile once and then configure it via runtime. So I can run the program. It will not fail as it has no arguments. And then I will go to the machine demo, just copy out this connection string for S7 and enter it here as program argument, and then we'll add db444 real, for example, as a field string. And if I run it now, I hopefully get a value from my S7 PLC. And you can see here in the example, Yeah, I got the response, okay, and I got the value. And now I will quickly do the same with OPC UA. So just give me a second. So with OPC UA, where I copy this rather long connection string and enter it here. And as connection string, it's ns5s equals counter 1, Tim, right? Okay, excellent. So, and now I will start exactly the same program,
Right, yeah.
just with different program arguments. Show the console again, and as we may, this is one thing you receive. OPC UA has a richer protocol, so they have several handshakes and exchange of information. Therefore, it takes really a bit longer. And you see again the read succeeds. I get the response 21. So here you really see the value of this single API, basically, because now if a customer comes around and says, okay, but I use Modbus ADS, your tool is nice, but I cannot use it as I use Modbus or backup ADS, then you just have to get the driver in during the runtime, and you can use it exactly the same way. Okay, so this basically sums up what we wanted to show you today. Demo time is over, and we are now open for questions. A good question was asked whether it's it's always basically possible to read the values, or if the vendors are blocking them. So what the vendors do is to use proprietary protocols where they don't make the specification public. This is something that they do basically forever. There are some vendors with who make the specification public, and also what we saw when talking to vendors initially is some of them were nice and helpful and helped us to implement drivers for their protocols, and some of them said, okay, then we'll talk to our lawyers. For example, the Siemens S7 protocol is one of the best known secrets out there. It's, I don't know, roughly 20 years old. It's proprietary and never officially, the specification was never specifically opened up, but everybody knows it. And there are tons of implementations out there. But there are also protocols which we had to completely, basically, reverse engineer. So it's so-so. Yeah. But as we all know in the IT area, security by obfuscation is never a good idea. There will be a point in time where someone reverse engineers the protocol and knows the protocol, and then security is gone. I hope that helps answer the question, or that answers the question. Okay, any other questions? If not, a little announcement for the next week, next Wednesday. We always have webinar Wednesday. Next Wednesday, we will have a webinar about Apache IoT-DB, which is an awesome young project in Apache Incubator for a very, very fast and efficient time series storage database, so which fits very well with those projects. And if you like the webinars, or you have any questions or ideas for more webinars in English or other content we could or you would like to see, then just ping me or Tim or anybody else who's around here. So thank you all for watching. Have a nice long weekend and happy Easter. Goodbye. Yes, IoT-DB is next week.